Hypotenuse leg and corresponding parts of congruent triangles are congruent. Theorems. Given an isosceles triangle where line segment RE is congruent to line segment KE and line segment EA is perpendicular to the line segment RK, let's prove that triangle REA is congruent to triangle KEA. For the first statement, line segment RE is congruent to line segment KE. So what do you think is the reason, guys? Okay, it is because it's already given. Second statement, line segment EA is perpendicular to line segment RK. What is the reason? Good job! It is already a given also. For our third statement, angle EAR is congruent to angle EAK. What's the reason? Very good. It is the definition of a perpendicular line. Fourth statement, line segment EA is congruent to line segment EA. So of course, the reason behind that is identity property, since line segment EA is congruent to itself. Therefore, triangle REA is congruent to triangle KEA. What is the reason from that? Of course, it is the hypotenuse leg theorem. Second example. Triangle TPS is an isosceles triangle, and angle PIT is equal to angle PIS, and they are both 90 degrees. Let's prove that line segment TI is congruent to line segment SI. Let's go for statement number 1. Angle PIT is equal to angle PIS, and they are both 90 degrees. So therefore, the reason is they are the given. Second statement, line segment PI is congruent to line segment PI. The reason is the identity property or reflexive property of congruence. Third statement, line segment PT is congruent to line segment PS. So what do you think is the reason, class? Very good. It is the definition of an isosceles triangle. Let's go in the fourth statement. Triangle PIS is congruent to triangle PIT. And what is the reason, class? Great job! It is the hypotenuse leg theorem. Last statement. Line segment TI is congruent to line segment SI. So, what is the reason now? Okay, very good. It is the CPCTC, or the corresponding parts of congruent triangle are congruent, since we already proved that the triangle is congruent, or the triangles are congruent, therefore their corresponding parts are also congruent. Third example. In a given parallelogram, line segment DE is parallel to line segment CK, and angle E is congruent to angle C. Let's prove that line segment DC is congruent to line segment KE. In the first and second statement, where line segment DE is parallel to line segment KC and angle E is congruent to angle C, the reason is they are the and the third statement, line segment DK is congruent to line segment DK. And what is the reason again? Great job! It is the identity property of congruences since line segment DK is congruent to itself. Fourth statement, angle EDK is congruent to angle CKD. What do you think is the reason here? Very good. It is the alternate interior angles. And in the fifth statement, triangle EDK is congruent to triangle CKD. And the reason is the AAS theorem or angle side theorem, wherein the two angle of triangle EDK and its non-included side is congruent to the two angles and non-included side of triangle CKD. Last statement, line segment DC is congruent to line segment KE, and the reason is the CPCTC or the corresponding parts of congruent triangles are congruent, since we proved that the triangle EDK and triangle CKD are indeed congruent, therefore their corresponding parts are also congruent. Example number 4. Given the parallelogram where line segment EG is parallel to line segment DF and line segment DF is congruent to line segment EG. Let's prove that angle EDG is congruent to angle FGD. For the statements, line segment EG is parallel to line segment DF and line segment EG is congruent to line segment DF. The reason is they are the given. Third statement, angle EGD is congruent to angle FDG. So what do you think is the reason for this class? Very good. It is the alternate interior angles. For our fourth statement, line segment GD is congruent to line segment GD. So of course, the reason is identity property of congruences or the reflexive property, since line segment GD is congruent to itself. So next statement, triangle EDK is congruent to triangle CKD. The reason is, okay, DSAS postulate or side angle side postulate, since we proved that the triangle EDK has a two side and an included angle that is congruent to the two side and an included angle of triangle CKD. That's why it is the SAS postulate. So last statement, we need to prove that angle EDG is congruent to angle FGD. So what is the reason behind that? Very good. It is the CPCTC theorem, since we proved that triangle EDK and triangle CKD are congruent, therefore their corresponding sides is also congruent. That's why angle EDG is congruent to angle FGD because of CPCTC.